In this video, we will be discussing the treatment of steam-assisted gravity drainage wastewater. So SAGD, also known as steam-assisted gravity drainage, works by the following logic. Pure steam is injected into the top well where it heats the viscous oil, extracting it from sand. Due to the use of steam, wastewater is generated, and therefore it must be treated.
Existing wastewater disposal or treatment methods are to use tailing ponds, hot lime process, or ion exchange. Scope of this project is to take the feed water from the separator and to produce boiler quality water for reuse.
For the plant location, the facility will be designed for the Phase G expansion of Cenovus Energy's SAGD operation in Christina Lake, Alberta.
In order to introduce you to our designs, here you can see our whole PFD for the plant with 3 distinct sections: coagulation, media filtration, forward osmosis, and then the final extra stage, draw solution recovery.
The first stage in the wastewater treatment process is coagulation. Most of the non-emulsified oil is removed by the separator prior to the plant. Emulsified oil remains suspended in the wastewater. Chemical addition with high power mixing helps to break the charges or zeta potential between oil emulsions and particles. The particles can then sink to the bottom in the separator and the oil can float to the top. This will protect technologies downstream.
The secondary treatment step in this process is multimedia filtration. The purpose of multimedia filtration is to remove constituents, primarily oil and suspended solids, to reduce fouling for the next treatment step, which is the forward osmosis unit. Multimedia filtration operates by feeding wastewater through the filter bed where particles are caught in the filter media. For the purpose of this process, we will be using 3 filters containing a walnut shell media.
Here you can see the forward osmosis section highlighted in red. The forward osmosis section consists of 12 trains, and the reason forward osmosis was selected is we need to produce a high purity water, which membranes are good for, and in theory, forward osmosis should require less energy than something like reverse osmosis. Forward osmosis is simply the opposite of reverse osmosis. Instead of using hydraulic pressure to create a permeate, it uses the natural osmotic pressure gradient, which you can create.
Here we will be discussing the ammonium bicarbonate draw solution recovery process. This process will resupply the forward osmosis unit with reconcentrated draw solution. So the reconcentrated draw solution is necessary to produce the flux required for the forward osmosis unit to operate correctly. The objective is to take the diluted draw solution that enters this heated vessel to allow the following decomposition reaction to take place. The captured CO2 vapor enters into the downstream reactor with an incoming stream of water and ammonia solution to regenerate reconcentrated ammonium bicarbonate.
An important factor to consider for this plant's design is waste management. Waste management at an SAGD facility is defined by the Alberta Energy Resources Conservation Board Directive 81. It includes managing the water balance of the whole plant. So when considering the waste management of our plant specifically, we have to look at the SAGD facility as a whole. Our answer is really that we need a small recycle stream sent back to the beginning of our plant. The remaining waste will be disposed of using deep well injection. In conclusion, throughout our plant design, a few things have been highlighted. Really, the big part is that we're trying to scale up from pilot to a full-scale plant. It appears that we need more data before progressing to the plant scale. So this was just a short presentation to give you an introduction to our plant. However, we look forward to seeing you at Sarnia. Thank you.